Hello, everyone. Thank you for joining our webinar, The Key to Mass Balance Optimization in Dairy Plants, Instrument Calibration Management. The speakers for our webinar today are Dino Holmquist and Soren Hansen. I'm Genevieve Randall, and I'll be moderating this webinar. Before we begin, I'll let you know more about how this webinar will run. The webinar is being recorded, and the slides and recording will be available for you through email within 3 business days. A short question and answer session will follow the presentation to answer viewer submitted questions. During the webinar, you can submit questions you have using the webinar sidebar menu. Select the Questions tab, type in your question, then hit the Enter key on your keyboard. Remember, you can submit questions throughout the webinar. Now I'll give a quick overview of Eurofins. Eurofins is driven by our mission to contribute to global health by offering the highest quality testing, training, auditing, and consulting services. We strive to listen to our customers and not simply meet, but exceed their expectations. Our footprint is global, with over 45,000 staff in 650 laboratories across 45 countries, and a portfolio of over 150,000 analytical methods. Eurofins provides a unique range of analytical testing services to the pharmaceutical, food, environmental, and consumer products industries and to governments. On this slide, you see all of our milk testing locations. Now I will pass it off to our speakers.
Thank you, Genevieve. Today's topic about managed calibration is going to be about why some dairy farms are more successful than others. I've been visiting many dairy farms, and one thing I've realized is that some of them are very good in efficiency and in terms of quality, and eventually also at their bottom line. And what I've been looking at is, why are these dairies so much better than everybody else? And this is what the talk is going to be about today. But before I go on, I have my colleague, Soren Hansen, who's going to introduce you a little bit about the milk business in Eurofins and give you a little bit of history of why we have been doing this. So I'll be with you in a couple of minutes. Thank you.
Yeah, hello everybody. My name is Soren Hansen, and I'll just give you a brief introduction to Eurofins milk testing. The Eurofins group provide analytics for the whole entire food value chain from farm to fork. And of course, close to our heart is the cattle and dairy business, where we actually have our main business. Just to let you know, we are actually not the newbies in this business. We have been on board, or we stand on the shoulders of generations of milk testing people. It started in Denmark in 1857. Perhaps I should mention that you can see, even though I share hair color with this gentleman, Mr. Steins, I'm not at least in family with him. And you can also see, we just took a picture of the protocols. We have actually the protocols dating back to 1857, and it's both amazing, but it's also a little bit scaring that when we read the minutes of Mr. Steins from his visit to dairies and to the farms, the battle we have today for better quality, the battle for preventing food fraud, actually that was the same situation Mr. Stein faced 161 years ago. In Eurofins today, we do milk testing across the Atlantics in North America and in Europe. We actually do 9 million samples in North America, 8 million in Denmark, little less in Sweden, and then we run small operations in Poland and Italy. What's very important to stress by this is that we bridge the globe in milk testing, and our internal experience in the milk testing is very important to the way we address our customers in the milk calibration area. Actually, I regret I'm not in family with Mr. Steins. I wish I hadn't, because I wish I had known what I know now. I wish I had known that at an earlier stage in my career. I spent, yeah, amazing. I've spent 25 years of my life managing dairies in another part of Europe. I have been manufacturing cheese, white milk, fermented milk, butter. Yeah, actually all the product portfolio in dairy production. And I was, of course, aware of consumption of personal cost, maintenance, energy, packing material had a big impact on my PL. But all the way, I knew that the major impact came from my mass balance and for the value chain optimization of my fat and protein that had the most significant impact on my profit and loss. I also have to admit to my colleagues in Eurofins and to the generation of milk testing people in Eurofins that I had my focus in the production. I was focused on the amount of cheese, the amount of butter. I was not that focused on the site laboratory. So changing business to this world of analytics, I've become much more aware of the impact of the calibration procedures, and I've become much more humble to the required knowledge and competences necessary to run the labs and the dairy operations, and much more humble to the competences necessary to provide efficient and valid KPIs to the dairy operations. I know many of our listeners come from the north, from the US, and have you ever considered with the amount of milk produced in the US a year, approximately 220 billion pounds of milk, amazing amount of production. Have you ever considered what the impact of inaccuracy in the milk testing means for the value of the whole US milk production? I just calculated this morning, and just 0.0% in deviation in milk and fat reflects an amazing amount of $85 million in value for the US milk market. And this is just also another example I would like to share with you, provided that we are a dairy now, provided we have an intake of 4.2 fat and 3.4% in protein. We can set up a mass balance in the raw milk intake. We have an intake of, this is, I think, a very normal size dairy in your countries, 1.3 billion pounds intake. And just an accuracy deviation in the butter, fat, and protein measurement of 0.2% ends up yearly loss for the day of approximately $1 million. But that's not you can say the most significant part. The most significant part comes from the product standardization itself. This is from my past, a portfolio in products covering dairy producing milk for the consumption, for the consumer market. We produce cream, whole milk, semi-milk, and skim milk. And with accuracy deviation for cream, for example, 1% and 2%, we have seen those inaccuracies visiting dairies in this part of our business. And added up for inaccuracies in whole milk and semi-milk, we end up for this example and this dairy end up in a value impact of $9 million yearly. So surely, that's why I say I just wish I had known what I know now. I had known that before, because then I would have really have paid much more attention to the calibration of my instruments in the site laboratories. But luckily, I have my young colleague here, Dino, and he has now told me he will now take me through the history of milk calibration in Eurofins. Yeah.
Okay, thank you, Søren. So here I would like to present to you what are the impacts of a dairy farm to improve their efficiency and also their economics, as San just showed you. But just to give you a brief introduction of what a milk laboratory in Eurofins looks like, we have divided that into 3 divisions. The first division on the left, we have our settlement analysis, where we are determining the quality of the milk in terms of the settlement between the farmers and the dairy plant. Next, we have the dairy herd improvement, or what we call the DHI, where we analyze single cow analysis in terms for the farmer to actually improve his or her efficiency on the farm. And in that, we also do veterinary analysis in order to prevent diseases and also eliminate most of the diseases in cows. And the last thing, which I'm going to talk about today, are our calibration services, where we have a single product, but we also have a service that we offer today in terms of a managed calibration service. To give you an example what these products means at a dairy plant, we look often at these slope bias corrections, which means that we have a certified value and then we measure it on an instrument, and next you want to adjust the instrument in order to have a mass balance. So we can have that at different lines or different products depending on how the setup is. And as Søren just told you, the mass balance is about how much milk comes into the dairy, it's processed to finished products, and then afterwards we look at how much of the finished products we have eventually produced. We have an expectation to have the same amount of say butter, fat, protein, etc., and the same amount of butter, fat, and protein in the finished products as well. So most of the dairies, say here in Europe, are co-ops, which means they're owned by the farmer, and that also means that you're also not interested as a dairy plant to cheat the farmer to be underpaid if you have taken too much butter, fat, and protein on your site. So that's a balance that needs to go up. On the other hand, you also don't want to say cheat the consumer to actually claim that a cream has 38% of butter fat and having lower amounts. So that's what I'm going to go through with you today. So in general, we have 2 different sets of categories of these products, of calibration samples. We have the standard calibration samples that you might know. Here in Europe, or in Eurofins in Europe, we are producing the calibration standards on Monday. We ship them on Tuesday, and then they're received the next day or the day after at the dairy plants, and then the certificate is ready the day after. However, we also do have another set of services which looks like a little bit like a ring test, giving the dairy opportunity to actually look how they perform compared to others. And this we call the managed calibration service. Here we still have some samples that we send out to the dairy plants. They will receive the samples and eventually measure them the same day or the day after, depending on their schedule. Then they will report us the results back, together with some more information regarding their instrument settings. And then we will provide, a couple of days later, we will provide a report telling them their performance, both in terms of how they perform in terms of to the reference chemistry, but also compared to others. So the managed calibration service is what I'm going to give you an introduction of today, and also give you an introduction of why these very, very successful dairies do it, say, so much better than others. This is an example of a real customer that we helped out just approximately a year ago, or a little bit more than a year ago, where they had 4 different product categories. They had whole milk, they have cream, single and whipping cream, what we call here, and then double cream. And we can see by their slopes here that they are very, very much off of the reference chemistry, which means that if they have measured, say, 38% of butter fat, they have actually realized to be 39.5% of butter fat. And that story we saw throughout the whole different products. And I'm sorry to say, but they have been doing this for actually many, many years. After we have done the alignment for them, and we went through all of their settings, etc., and do the very, very thorough calibration of all their instruments and all their product lines, we have actually been able to save them up almost $300,000 just in 2 years. So they had an annual loss of approximately $420,000 per year, and now they have approximately $130,000 in loss. And we are still working on how to actually bring that even lower down. I'm not going to be naive and tell them that they're going to be zero, but as long as you realize that you might have some loss, then you will have to find out how much loss you have. And that's the whole purpose of revealing this type of service. Another example, I'd like to show you how we also help our customers to overview all of their sites. This is another large customer who have different sites, and on each site they have an instrument, an IR instrument or an FTIR instrument, where they're measuring their either finished products or incoming milk or both. Here we have an overview of all the different instruments which are lined on the x-axis of this graph. And here we will show say for instance, here we have the protein, where we see the 3 months average on all different sites. On the left, we will see the sites that are very, very good in calibrating their instruments. This is a residual plot, which means that everybody should aim for 0. The variation should be 0. And they have a very, very strict limits of plus minus 0.016. So these are the limits that they aim for, and you can actually see that very few sites have a variation higher than that. And because this customer have been using this type of service for many, many years. Usually we will start at 0.04 or 0.06 and then narrow it more and more down to say this could be a very, very optimal situation to actually have these very, very narrow limits. As Søren also told you, just an impact of 0.02% may have a huge impact on the revenue for the dairy plants. So a question I often get when looking at the normal set of calibration standards, where the customer get the calibration standards, they will also get the results, and you will probably never hit the exact spot from the reference chemistry, which means I will often get the question of how often should I calibrate my instruments, both how often and also should I adjust the instruments. What we usually look at is the fluctuations of the calibration. This is again just a thought example of how we see many of dairy plants which are chasing the right value, which means that you will have a huge variation. You might be precise but not very accurate. On the other hand, we also see sometimes examples of where you can be accurate but not very precise. So what you eventually want to do is you want to lower the fluctuations of your calibration, but on the other hand, you also want it to be more flattened instead of having a broad variation. Another way of looking at how often you should calibrate is what we call pilot samples, which are a single point of analysis. These are not calibration samples, but this is a uniform milk that you use to see that your instrument does not drift. This could also be a very, very useful tool to establish the question or the answer for how often you should calibrate is by looking on your deviations on your pilot samples, and these should definitely be run on a daily basis, and then this could give you a clue of how often you should calibrate your instrument as well. So again, the pilot samples cannot be used for calibration purposes, can only be used to give you an indication of whether your instrument drifts or not and how much it actually drifts. So the next steps to be able to realize this kind of service is to be aware of the pitfalls and the possibilities in a dairy plant. First of all, one has to be aware of the mass balance in the production flow chain, which means that one has an intake. We have analysis on the intake. Second of all, you will have an output. We can also do analysis on the output, which means finished products. And on the other hand, some dairies also have the opportunity to take some intermediate products out to actually check that the products are what we think they are. All of this has to come together for the optimization of the analysis instrument. because most of you will definitely measure a product, and the instrument will probably tell you the correct or an answer, but that answer we have to ensure that it's as correct as possible. So an analysis instrument consists of many features, and some of them we often also see that the software or even firmware at the instrument might not be alike, even on the same dairy plant, which might have 2, 3, or 4 different instruments or the same instruments, but they will eventually have different software versions on these instruments. That's definitely a no-go. One has to have uniform instrument software in order to perform at least somehow adequate. Then you will have to have a standardized protocol for calibration purposes, which means that you must standardize how often you do it, how you do it. We often see different people at different shifts will tend to use the calibration standards differently. That needs to be standardized, and also the frequency, which I have introduced today as well, needs to be standardized. And then one has to use the same calibration standards. It's not good to have them from different sources, especially because the reference chemistry might not be that accurate in terms of the use at the dairy plant. And then the most important part is actually to repeat the whole steps. This is not a once in a lifetime or once in a year process. It is a continuous process to be able to reduce your variation in calibration. As I showed you, one of our customers that have been successful and reduced the variation, and they have a criteria of 0.016%. That is the optimal, I will say, limit you can have on your instruments, and that's only done because they have been aware of it and they've repeated it week after week after week. So this brings us to the last slide of our presentation today, which I hope you've enjoyed and also got some inspiration of how it could be done at your place. And I will like to have some questions if you have anything, or any comments, suggestions, or anything. And to the last, if you are interested in any of these services, either the calibration samples themselves or our managed calibration services, please do not hesitate to get back to either Kevin, Chris, or myself. Then we will definitely see how we will be able to help you as well. And so thank you, and I hope you have enjoyed it. And Susanne and I will be here to answer your questions if you have any. Thank you.
All right, so thank you, Dino and Soren, for your presentation. Now we'll move into a short Q&A session. During this, feel free to continue to submit questions, and speakers will follow up with any questions that they don't get to. Our first question is, do you offer consultancy in calibration directly at the dairy site, and how is this invoiced?
Yeah, that's a good question. Well, it's we often either offer a full package depending on the situation, or we can do on an hourly basis. That's all up to the customer himself. We can look at the whole site, or we can look at if there are different dairy sites. We will then offer a whole package of services to all their dairy plants. So it also depends on how they are structured at the dairy plants. Yeah. Emily?
Yeah, we do address directly to the dairy plant. Yeah.
Okay. Our next question, do you provide customized reference material, example, manufactured on a customer-specific milk?
Mm-hmm. Yeah, that's also a possibility. We do already have, say, in the US, we already have different types of customized milk. That could be milk based on a geographical basis, either from the north or the south or the east or the west. We can do special seasonal offerings or seasonal products like ice cream mixes, which are not always all the places seasonal, but at least, you know, eggnogs or some other types of products. So definitely yes. One thing I should mention is also that it is very, very good to look at the matrix that you are eventually producing or intaking at the dairy plant. That could also be like goat milk, could be very, very useful to also calibrate with, say, goat milk. And the same with the finished products. If you have some very special finished products, then you should also aim to have the calibration standards, which are as similar as possible to the finished products, because the IR spectra will reveal whether the product is say original or not. So that's a very, very important thing to actually consider, how to build up your calibration standards based on the product that I am actually want to measure at the instrument. Yeah.
Okay, that's all the questions that we have. I want to remind everyone that a recording of this webinar, along with a copy of the slides, will be available to you in 3 business days. This will come via email. Thank you to Dino Holmquist and Soren Hansen for their expertise and presentations, and thank you everyone for attending.
Thank you.
Thank you.